Hey there, tech enthusiasts! Today, I'm diving into the fascinating world of self-healing materials and how they're revolutionizing various industries. So what are self-healing materials, you ask? Well, they're exactly what they sound like. Materials that can repair themselves automatically when damaged. Imagine a world where cracks in concrete, scratches on your car, and even broken electronics can fix themselves without any human intervention. Pretty cool, right? Now let's get into the nitty-gritty of the technologies driving these innovations. First up, we've got autonomic self-healing systems. These materials contain embedded healing agents that spring into action when damage occurs. For example, imagine a fiber-reinforced composite that, when cracked, releases a liquid healing agent that hardens and seals the crack. Next, we have embedded microcapsules. These tiny capsules are filled with healing agents and are incorporated directly into materials like concrete or polymers. When the material is damaged, the capsules break open and release their contents, effectively healing the damage. And let's not forget about self-healing polymers. These are special types of plastics that can spontaneously repair themselves without needing any external help. Think of a phone case that can magically remove scratches overnight. Alright, let's talk applications. In the construction and infrastructure sector, self-healing concrete and asphalt are game changers. They can significantly extend the lifespan of roads and buildings by automatically repairing cracks and reducing maintenance costs. In aerospace and automotive industries, self-healing coatings and composites can enhance the durability and performance of vehicles and aircraft, making them safer and more reliable. And in the world of electronics and wearables, self-healing materials can extend the life of devices, making them more durable and cost-effective in the long run. Let's check out some real-world examples. One fascinating case study involves concrete embedded with bacteria that produce limestone to fill in cracks. This innovation not only extends the lifespan of concrete structures, but also reduces the need for repairs. Another example is self-healing polymers used in coatings for everyday items like smartphone screens and automotive paint. Imagine a car that can heal its own scratches or a phone screen that can fix itself after a drop. Incredible, right? Of course, there are challenges to overcome. One major hurdle is the cost and scalability of producing these materials on a large scale. Making them affordable for widespread use is a significant challenge that scientists are actively working on. There are also environmental implications to consider. While self-healing materials can reduce waste and extend the lifespan of products, the production processes need to be eco-friendly. Looking ahead, the future of self-healing materials is bright. Researchers are continually pushing the boundaries, exploring new materials and mechanisms to make self-healing more efficient and versatile. From medical implants that can heal themselves to smart textiles that can repair tears, the possibilities are endless. In conclusion, self-healing materials have the potential to transform industries, improve safety, and contribute to sustainability. They offer exciting possibilities for the future, and I can't wait to see how they evolve. Keep an eye out for these innovations in your own life and stay tuned for more updates on this incredible technology. Thanks for watching, and don't forget to like, comment, and subscribe for more tech insights.